Control. Going to do two quick summaries. First thing, AC motors, as you know from past discussion, variable voltage, variable frequency. Yep. Increase the voltage, increases the speed. You increase the frequency, you increase the motor speed. Because an AC motor basically gets a kick along every time the power gets to the top. When the power is at the top of the cycle, that gives the motor a kick along. That gives the motor a kick along. If I increase the number of kicks, it spins quicker. If I increase the strength of the kick, it spins quicker. That's how AC motors are controlled, varying the voltage, varying the frequency. DC motors are controlled, has it got record sitting on the screen there, red on the top?
Yep.
Okay. DC motors are controlled the old way, go back 40, 50 years, was they just stuck a big resistor in the circuit. So if you had 120 volts, for want of a number, coming in, that's a variable resistor, a resistor with a line going through it and an arrow. That chewed up most of the power. What you wanted to use, you left there, which then the voltage went across to the motor. Very inefficient. Very easy, but very inefficient. So that was the very early trains were controlled like that, going through until about the 1970s. These days, as I said, they're controlling trains with AC. But modern DC control is with pulse width modulation, which means if that's, let's pick a number now, 5 volts, that's 0 volts. And let's use electronics to turn it on and off at around about 1,000 times a second. 300 to 1,000 times a second. We are flipping the 5 volts on or off. So if I flip that on for 50% of the time and turn it off for 50% of the time, what's coming out the back end, it just sees 50% of 5 equals 2.5 volts with no resistance losses. Like that thing I just rubbed out, the old school losses just aren't there because it's on or it's off. You're not wasting electricity, so it's far more efficient. Let's draw another one. Let's say we want 3.6 volts. 3.6 volts. I've got to do the maths now quickly in my head. Is 73% on. So if I leave it on for 73%, and I turn it off for 27% of the time, then the average value, 73%, 27%, 73%, 27%, like so. The average value of that is 5 times 73 is 3.6 volts. That is pulse width modulation. That's how it works. That's DC motor control. AC motor control is variable voltage, variable frequency. Pulse width modulation is DC.